Welcome back, viewers. So, this is the concluding part of KVL, Kirchoff's voltage law. So, in this class, we are going to be taking some uh, some problems, and we're going to solve them. So, the first one we are having here now is verify. It says that verify KVL for the circuit in the figure below. So, of course, by now you should know that we have a two methods which we can apply KVL. So without wasting much of our time, we are just going to apply the first method. So as we have been told, the first thing to do is to what is to assign a direction. So it's very necessary. Let's make use of uh, clockwise, since our current is right in the direction. So the next thing is assign our polarity, and the rules to assign our polarity has been given in the former class. So though we can easily go through them again. So according to the first law, we are going to assign a positive sign for V or E if its reference polarity is from positive to negative. So that is exactly what we are going to do. So as we already know here, this is a negative terminal on this voltage source here, and this is the positive terminal. So since it is going in this direction, definitely it's going to be positive, negative, positive, negative as well on this one. This one is going to be positive and negative as well. So for this case, something has changed already. So we're going to have what? This is the negative terminal, and this is the positive terminal. So I think we are good with that. So the next thing we are going to do now is that we are going to pick out our um, our element. So and before we do that, we are going to look at the idea of KVF first method. It states that the summation of voltage is equal to 0. So it's from a summation of all the voltage that drops along the circuit and the one in the source, which that rise from the source, they are going to be equal to 0. So we are going to start from here. Let's start from here. So let's see. This one is already from positive to negative. This is going to be what? Positive V1. So this place we are going to have what? Positive V2. And on this direction we're going to have what? Positive V3. From negative to positive, we are going to have separate things here. Negative E2. And in this case, we are going to have what? Negative E1. Everything must be equal to 0. So now let's substitute our value back into the equations. So our V1, the value of our V1 is 2.5 volts plus our V2, which is what? 2.5 as well, 2.5 volts plus our V3, our V3 is 2.5 volts. Our E2 is different, which is giving us minus 5 volts. E1 is minus 2 volts. Everything equals 0. So if we are going to add all these things together now, we are having this one will be we are going to be having 7.5. So we are going to have 7.5. So and this one we are going to be having minus 7.5, which is equal to 0. So when you subtract this one from this, definitely we are going to have 0. Definitely the the KVL the KVL the KVL theorem is verified is verified. So that is exactly what we've been asked to do in the question. So I hope that is clear. So away from this now, let's take another question. So here is question 2 on our list. So in this question, we are being asked to determine resistance R3 in the circuit below. So this this is the resistance there. We are being given the value of R2, R1, and R4. So we are being given the source voltage as well as 5, but this is our major concern. The next thing we are going to do is to follow the rules. So we have to what, assign our direction first, as we have been doing. So I'm going to have what, I'm going to assign um, clockwise direction as well. So the next thing, I'm going to fix my polarity. So in this case of this source, where the voltage is rising, I'm going to have negative, because that's the negative terminal here. While this one is the positive terminal. So now, since the direction is in clockwise direction, definitely this one is going to be positive for a consistent direction, current direction, and voltage polarity. This one is going to be positive, negative, and this one positive, negative, as well, positive and negative. So now, if we remember from our Ohm's law states that V equals I R, but what we are looking for is around 3, so it's going to be everything related to 3 is going to be our component, which is V3 I. The I is the same because in a series connection, the current is always the same. So, and we have what, R3. So we are looking for our R3 now. We're going to manipulate the Ohm's law. We're going to have our R3 equals over V3 over I. So now the question here is, what is V3? That's the question here. So if we're going to find a V3, this is where we are now going to apply our uh, KVL, which is Kirchoff's voltage law. So which states summation of this voltage that rise from a circuit and the one that drops along the circuit is equal to 0. So, but before we can do that, let's take them one after the other. We already said V is equal to IR. So we have to know, we already know the V. We already know the current, which is the common current to everything here, which is our current is what, is equal to 0.25 ampere. That is very, very important. We should first take note of as our parameters. So then we can now apply our KVL. So that is when after that we can now apply our KVL. So how do we do our KVL now? So we are going to find the voltage across each of these components. So we already know that of this one to be 5 volts. We don't know of this one. We are going to have so everything here is going to be V1 equals IR, which is going to be I multiplied by R1, so which is the same thing as 0.25 times 2.5. So in this case, we are going to punch our calculator on that. So our V1 in this case is going to be 0.625 voltage. So likewise, the same way we are going to calculate for the remaining the voltage on the other component as well, element as well. So this is it. We have already got the value for the remaining voltage. So the V1, we multiply the common current by the what, by the resistor of that unit. So the same thing applicable to V2 is going to be 0.25 times 5 ohms here. The V3 we don't know, that's what we are looking for. So but since we do not know the R3, we are going to be done, there's nothing we are going to do to that. So our V4 as well is going to be IR4, which is 0.25 times 4, which is the value of ohm in 1. So we've got 1 volt. So now to get our V3, we are going to apply KVL. Applying KVL now. So we're going to have V1. Please don't forget the polarity as well. It follows. this v1 uh, plus v2, and this one plus v3 plus v4 minus uh, minus this uh, minus e2, because now you see e2 is what is going from minus negative to positive terminal. So that is against, it's not consistent with the direction, so which is in opposite direction. It's against the direction of the it's against the reference direction, so we're going to have it as minus. So everything will be equal to 0 according to sum of the voltages rises and drop, which is equal to 0. So let's substitute our value. Our v1 is what? 0.625 plus 0 plus 1.25 plus 0, sorry, plus v3. So that's, I'm looking for v3 plus, sorry, plus v4, which is a single vote, and uh, this one, which is minus 5 equals to 0. Minus 5 volt equal to 0. So now if you are going to add all this together, maybe you are going to punch our calculator again, which is 0.625 plus 1.25. So we are having 1.875. 1.875 plus V3. So what are we having here? Remember, this one is in voltage, this one is also in voltage, this one is also in voltage. So I'm going to have minus 4 volts on this side, which is equal to 0. So away from that now, we are going to add uh, 1.875 minus 4.4 voltage, so which means that we are collecting the like terms. So by so doing, we are going to have so what we're having now is going to be minus 2.125. So if you take this to the other side, our v3 will give us positive 2.125 volts. So that's the value of our v. So now we can take this back to our Ohm's law from the beginning that we have here. So this is what we are going to use. So which is what we are going to recall. So we are going to recall our formula, which is R3, which we are looking for, is equal to V3 over the R. So we are going to have V3, which is this 2.125 over R currently 0.25. So let's punch our calculator together. So I'm going to have 2.125 divided by 0.25. So our answer is finally 8.5 ohms. And the last question for today, this is what we are going to have. Using Kirchoff's law, find V1 and V2 in the figure below. So if you look at this figure, so we have multiple closed loop in this case. So which is also a little bit different from what we have been doing. So there's nothing bad. We are still applying the same rules. So we can call this one a particular loop. We can term it a loop. We are still following our direction. That's the first thing we do. The reference direction should be what? Should be assigned. According to what we have here, the polarity has been assigned to this question. So all we just need is to assign our reference direction. That is what I just did. So now let's take it one after the other. We want to find V1 and V2. So how do we do this? Excuse me, there's no space. Let me manage this sheet. So you can call this one loop A, call this one B, call this one C. So, and it doesn't matter any one you pick first to analyze, but what the answer is for your answer to be correct. So if you look at this circuit now, you look at our loop C is very straightforward. So if you like, you just have just two components here. So while loop A we have four components, if you look at it, and this one we have three components. So you can use our two components to easily get our answer. So I will advise you to follow your direction. You can see, and the rules that we have been following from beginning based on Kirchhoff's law is that, and reference direction method. When you are going from positive to negative, it's going to be what? It's going to be you are going to assign a positive. So definitely our V3 here is going to be what? Positive V3, positive V3. So we are going. So you are coming like this. On the other hand, you are having, in this case you are having something different. So which is what? Negative to positive. You are going to have negative 5 volts. So don't forget what we are using is what? Uh, is equal to 0. Equal to 0. So this is going to be what? V3 equals to 5 volts. So that's the value of our V3 for the first one. Now let's take another loop again. So now this one is what? For loop C. Now let's look at another loop. Let me just take loop A. Loop A now. In loop A, we have four components here, or four elements. So we are going to follow our direction. I'm starting from this side, which is our 30 volt and 30 volt. If you look at this one, from positive to negative, it's going to be positive. So we are going to have what? We are going to have 30, positive 30. So our V1 is still positive, positive V1. If you go into this one, in this case, we are a little bit differences has taken place. So this is going to be what? Negative to positive. So it's going to be what? Negative V3. So going back to this one as well, it's going to be negative 15V equals to 0. So already we've gotten our value of V3 to be 5. We can easily put that straight. So let's just do this. So from here now we can collect our like terms. We are going to have, if we collect our like terms, we have this one together. We are going to have 20, that will be negative 20. So we are having V1 plus um, 30 voltage, negative 20 voltage equal to 0. So at the end of the day, we find that our V1 is going to be 10 voltage. So that's the V1. So we are not done yet. The last loop we are going to be taking is a loop B. For loop B now, so that is where we can get our V2 we are looking for. So let's follow our direction as well. So which is, this one is from positive to negative. So which means we are going to assign what? We are going to assign positive. So we are going to have assign positive, which is positive. So don't forget this one is as already, it will not change. Positive, negative. From positive to negative is plus V2. So there's nothing here. Going back to this one, from negative to positive, which is going to be minus V1 equal to 0. Don't forget what we're still using, is equal to 0. So what is happening here? I hope we understood what happened here. So is that what we are assigning originally according to our rules is positive, but already we are having negative value of voltage here, which means what we are having here is voltage drop. Definitely it's going to be minus. So instead of us being confused by using the second law, so it's better to just follow the arithmetic straight, so that we will not get confused. So I could have taken us back to the rules, because there are still rules that we should apply negative when the direction and the polarity are not the same. So now in this case now, I think we have done justice that when you multiply positive by negative, you are still going to have your negative 15 volts plus V2 minus V1. So what's the value of our V1? Remember, is what? Is minus 10 volts, which is minus 10 volt equals 0. Minus 15 volts, if you're going to do this, plus V2 plus, so it's going to be negative times negative is going to be 10 volts equals 0. So by the time, so we're going to have uh, our V2 to be 5 volts. So that is after we have subtracted this from this, and we are having minus 5 volts. So that is the final answer in this case. So we have done justice to this particular question. So that is where we are going to stop on uh, current voltage law solutions. If you have any question, you can forward it to our email, online series. So you see it on the screen, and if there's any question you want to post, you can post it and send it to us. We will do justice in that. Please leave your comment as well, and to watch and enjoy much video, please subscribe and like our YouTube channel. Thank you. Goodbye.